I'm Katie Beek, and I'm speaking to you today from my office here in Baltimore. I'm going to imagine that all of you are here in the office with me, but in reality, I'm up on the third floor of my house, hiding from my children and pretending to talk to you, but actually talking to this figurine of a Dalmatian and this Russian nesting doll, and also the pets.com sock puppet. So that's my audience for real, but I'll be thinking of all of you. And I'm going to speak today about how to design visuals that communicate your message clearly to your intended audience. And my goal is to help you get get what you see in your data across to your readers effectively. And I'm going to hope that the principles I talk about can be applied to all manner of communication, but as a sort of a case study, I'm going to focus on the scientific chart. So I'm going to start with some definitions of the parts of the scientific charts. So this is the scope of the chart. Here is a sample chart that I have made up entirely. I put some dots in a scatter plot and added all the chart things. So my goal is to walk through the choices that you make when you're designing one of these, and how each of those choices can help you make your point more clearly or more strongly, or just make the figure more readable and legible, which will ultimately help your reader understand what it is you're trying to say. So I also want to point out that I consider the caption to be an integral part of the chart. So I'm gonna include a little section on caption writing at the end as well. Before I get into all that, I'm gonna take a small aside to tell you a little bit about who I am and where I'm coming from, which I hope will give you a little bit of perspective about, what's driving my recommendations and also sort of the limitations of my expertise. So my day job is a freelance scientific data visualization designer. I work on things like this. This is a page I did for the November 2020 print edition of Scientific American. It's about the flu and how, with all of the COVID precautions and social distancing, mask wearing, hand washing, all of that has basically just like tanked the transmission of influenza around the world. And so this was a piece I did back, it's the November issue. So this was actually done in August and September. So that's why my data, can you guys see my mouse? You can, I think, see my mouse. The data only goes to August, but the idea was that, the regular flu season started in the Southern Hemisphere, because of course in the Southern Hemisphere, the flu season is reversed from what it is in the Northern Hemisphere. And then as COVID precautions started dominating how people interact, flu transmission is just gone to zero. And I did look it up, but I don't think I have that window open right now. The zero line has absolutely continued through the end of 2020. Like, flu is just gone. Anyway, so this is the sort of piece I do. I come up with this idea. I have, some question. I'm like, what is happening with flu? And I have done enough research on flu in the past that I know the sources to go ask about it. And I know where to find the data, and I do all the data cleaning, and I create the visuals, and then I also write all of the text that goes onto one of these pages. So this, these pages take me a long time, but they sort of represent like the full nose to tail process of conception to how are you going to visualize it, how are you going to add text and like really communicate a point clearly to the reader. So it's pretty similar to what, the much more smaller and more straightforward, perhaps less elaborate chart does. So I'm sort of adapting a process that I do for a general reader and sort of a mass audience, but I'm going to adapt that to hopefully to your needs as working science. So, this is another example of the sorts of pieces I do. This one is in the February issue of Scientific American. I work with them fairly often, but I also work with the Times Magazine, Audubon Magazine, and a few other sort of science publications. So this one is on newsstands now, if you happen to be in an airport. This one's about how the pattern of dinosaur fossil finds is shifting as more paleontologists are being educated and working around the world. That there are now, Chinese educated and paleontologists working in China. There are Argentinian educated paleontologists working in Argentina, and so like having paleontologists on the ground is leading to new areas of fossil discovery. And this, you can read all about it, but on some level, the pattern of fossil discovery follows the pattern of just where the paleontologists are. So this piece sort of explores that a little bit. And so this is the sort of bread and butter of my work life. And I wanted to give you a little background about where I came from and how I have gotten to this point. I did start my career as an astronomer. I did my my graduate work at Berkeley, doing stellar spectroscopy and other sort of observational things. I've got, I spent 80 nights observing at Keck. Like I definitely was all in on observational astronomy. And then my spouse is also an astronomer. And throughout grad school, I was sort of like loving the observational astronomy, but also like the time scales of the projects was a little bit too long for me and the scope too narrow. And I just started to have the notion that I could learn. I just wanted to like explore, let my curiosity roam about how the world works. So after I finished my degree, I did another degree at NYU. So this was me moving to the big city. And I did a degree in science journalism there. And so I really honed my like nose for stories and what's interesting. And really the shift in grad school in second grad school was about how like part of your job as a mass communicator is not just to like convey things on a level that people get, but it's also to like grab their attention. And, your reader doesn't have to keep reading. They can flip the page or swipe away to something else very easily. And so part of what I learned in graduate school was the craft of taking an idea and making it accessible and appealing. And so I think that's part of what your charts have to be able to do is just like a few simple design things can help make them just grab your reader a little bit more, and that will help your readers get the point that you want them to get. And so then, anyway, I did a lot of writing. That was all writing journalism. And then I started, after journalism school, I started on the staff of Popular Science magazine, but I started actually in the art department because I had decided somewhere along the way that data visualization is really where I wanted to be. So I had been doing some work on infographics, and the art director at the time sort of has been a great mentor throughout my career and taught me a lot of the fundamentals of graphic design. So it was very much on the job training, so that this is my like graphic design icon here. So there's a lot more like art and design in my life now. And the abacus is here because to remind me to say that I now do like very simple data analysis. Like I ultimately, because the pieces I do I'm not the expert, I wanted to be taking data sets that experts have worked on, and I speak to those experts. It's the journalism and reporting side of things to make sure I understand them and their limitations. And I'm always like very careful about how I present them, but in practice, I keep the amount of analysis I do on those data sets to pretty much a minimum because I just have this principle that I can't explain in a few sentences to a reader what I've done to the data, then I'm probably doing too much. So that's sort of like the story of where I've come from. My roots are in astronomy, but I've like just taken this very circuitous route through journalism and then like narrowed it down to data visualization. And that's where I am today. And I also want to confess that I am a little bit of an astronomy dinosaur in that I did not do the bulk of my astronomy work in Python. And I have only a passing familiarity with Matplotlib, which is what I'm going to be asking you to do your assignments in or your workbooks in. So I'm going to present what I'm presenting today with some basic understanding of how your software works, but I'm going to focus on the principles and sort of trust that if any of these, like if there's something that you want to do to make a chart look a certain way, that I'm probably not precisely the person to ask to do that in Matplotlib, but I can help just sort of like guide the choices, then more generally speaking. So to start, I think the best way to approach design is to have an idea in your head of what it is you want your chart to say. And so I think of that as the point. In journalism, we call it the angle. Like it's the thing that your chart, like it's the difference between a chart that just shows something and one that is making an argument. And sometimes a chart is just going to have to be in a paper and show what it needs to show because that, information has to be in the paper and whatever. Maybe there's no point to be made. But if there is like a core argument that your paper is making, it might be good to make that point both with words, but also visually. Like if you can make a chart that lays out the same argument that you're making in your paper, it'll just strengthen it, especially with, different readers learn things in different ways. And some people need to read the text and some people get it much more quickly with a visual. So here I've just, sort of made up, without thinking about it too hard, a few different visual approaches to the same totally made up data set that I had a few slides ago. So, on the left, I've, maybe these dots are stars and there's two different types of stars or populations that you could call out with color, and maybe they've got some like property that's different. And so I made this, histogram on the left where, you can see that it's a slightly offset in the whatever quality this is in the distribution. Or maybe it's just a simple, fitting a trend to data. Like no matter the complexity of the point that you're trying to make, you have to make choices as you're putting together your chart. And so if you have an idea of what point you're trying to make and the argument that you want your chart to be making to your reader, then that it can help you guide all of your design choices that you have to make, like whether to visually emphasize the trend or visually emphasize a difference in populations. Like those are design choices, like whether the dots stay black, whether they get colored, that when you're making those decisions, you'll have a point of reference to return to say, does this strengthen my point or not? So I recommend framing that point in a sentence or two, sort of like an elevator pitch. For me, when I'm doing a piece for Scientific American or whatever, I really like hone my headline before I even really get started. I mean, the actual text of the headline I usually write last, but at least I know what idea the headline is gonna be conveying. Like, I knew with the dinosaur piece that I wanted to show where all the fossils were from, but the point I wanted to make was that the fossil discoveries follow the locations of the people. And so I knew the argument or the angle that I wanted my piece to have, and I could make design choices that informed that angle. And so if you have that written out concisely at the beginning, then you can use that as a guide for the choices that you're going to make down the road. Another thing that's important to define is the audience. So this will help you, this will obviously govern a lot of the choices that you make, because for a paper for someone who works in your specific subfield, or something that you're doing for maybe a workshop talk, you're not going to have to explain a lot of the jargon. You can use references to other work that without explaining too much what that is. Maybe you're writing a paper that's going to be read by another astronomer, but not necessarily someone who's in your subfield, in which case you'll have to explain a little bit more of the terminology and be a little more broad about how you make your choices, but you can still trust them to sort of understand the conventions of the field. Another possible audience is a fellow scientist, but not necessarily an astronomer. Like if you were making a paper to be published in Science, for example, you would need to explain enough that another scientist who doesn't know the conventions of astronomy would be able to understand what it is you're saying. And then sort of, I've put it down in the corner a little further away from the rest because it's a bigger leap, but possibly you're doing something that would be reaching a general audience where, the person is curious, educated, but by no means an expert. And you'd have to be very careful in that case about not assuming really much of anything about their background in the field that you're trying to make your point in. So, for each of these, you probably don't need to think very hard about what your audience is, because you know why you're making the figure. And so that's a little bit self-explanatory. But one thing that I find useful when I'm writing something is to imagine my audience not as like an audience, but instead as a specific person. So I guess that's kind of exactly what I've done here with my figurines. My general audience has become specific people, if stand-ins for you guys. So for example, when I'm writing something for the general audience, I have a few people that I like, specific people that I know who I keep in mind. So, I have an aunt who is super smart, but sort of self-professed, not scientific person, and not particularly quantitative, but very like engaged and curious, and I think about her pretty often, because if I'm writing something, I sort of will stop and read it back and say, or designing something, I'll stop and look and ask myself if she would be engaged by it, if she would be able to follow the argument I'm making, if she would understand all the parts. So, here I've imagined some of your fellow, some of your audience members, like maybe you're thinking about an old advisor or a sort of grumpy, this is your grumpy colleague who sort of doesn't quite truck with what it is you're saying. Maybe this is your sign. That's the science of alchemy, apparently, and queenliness. My emoji set was limited for this slide. I guess my point is that if you write to a specific person, it really, I think, helps engage. It helps you see it from someone else's perspective and see where you might be making leaps about that person's understanding, or things that, your head is so deep in this data when you're making these things that I find it really helpful to remove myself and look at it with fresh eyes. And one way to do that is to be imagining a very specific other person. So when you are making a figure, there are many different kinds of charts that you can choose from. For the most part, if you're designing for an audience of astronomers, in my experience and my intuition is that the chart type is going to be pretty well established by convention. But it might be helpful to have other types of charts in mind, just to help you hone a little bit and just make sure that you're using the right one. So there are resources like this. This is just a compendium that was put together by the Financial Times a few years ago. I'm looking for a date on this. Oh, it was a while ago. And I don't have this included here so that you can read all of these, but if you want to look it up, you can. And this is obviously visualization types for people who are designing for a general audience, a publication. This is like a designer's reference. And you probably don't need quite all of these options, but it's, I occasionally find it helpful because I tend to get stuck in a little bit of a rut sometimes where, the first thing I start with as an idea for how to represent something visually is just the thing I used last time. And if you find yourself, maybe you're not sure quite how to represent the data that you want to represent, it might be helpful to just take a look at the options that are out there and see if any of these, or there are many of these types of compendiums of visualization strategies. There's I think Data Wrapper and Plotly and Tableau, all these like online data visualization apps will also offer many of these. So there's plenty of places to look for this sort of resource, but the idea is that you might be able to shake yourself up out of your old habits and maybe find something that will make the point that you want to make with the data that you have. Because ultimately the type of chart that you choose, this is the type of chart that you choose is going to make your points differently. So that flu example that I showed you, that's on the left there, the chart that I made as it appeared in Scientific American. And what I did, for a workshop that I spoke at a couple months ago in the Netherlands to an audience of data visualization specialists, I tried taking this data and envisioning many other ways of displaying it for different audiences. And so I tried, how would I show the same data for kids? How would I do it for an expert audience? How would I do it for an audience of generalists? And so here's just one of the other ways I cut this data apart into what I call a lollipop chart on the right, where all I'm doing is I'm taking the peak of the flu outbreaks each year and just charting that, because the peaks all happen at different times, but ultimately that's sort of what you're doing visually when you look at the chart on the left with all of the curves. The curves are there to give the reader a sense of what a historical flu season is like. And they all vary, so including many of them helps you get just like a visual sense of the average. I am including, this 2009 curve actually did not appear in the Scientific American version. This is the version for a hypothetical expert audience for that talk I gave. Because 2009 was the H1N1 variant and the swine flu. And so that was just a weird year, but I felt like it was a year that an expert would remember and want to see on this chart, just for reference about how this year's weirdness compares. Anyway, I didn't quite intend to include that in this talk, but now I have. My point, ultimately, I think that the chart on the left with the full-time curves is more effective because you can really see how it starts as a normal flu season and then just drops. And I think that's the ultimately like the most interesting takeaway, that even in the US, where the flu season was naturally tapering in March anyway, it just tanks much faster than it ever did before. And I think, ultimately this lollipop chart approach, where the point is that the dots for 2020 are much lower than the dots of previous years. It's streamlined, but I think it's not quite as effective. Anyway, my point is that when you're choosing a chart type, you want to think about whether that type is making the point that you want it to make. So the choice of chart is going to, you want to choose a chart that is going to make your point. And by that, I mean, so I'm sort of like saying the same thing twice on this slide, which is why they're on the left and right. So you want a design that's going to make your point clearly. And the way you do that is by having it be the strongest visual element in the chart. And so if it's the strongest visual element, that's where the eye is going to start when you're reading it as a reader. And that'll help your point sort of come to the fore. But also, you have to include enough information that the reader trusts what it is, that what you're saying. Like, you have to not show the conclusion, but also show the evidence. You don't want to just draw a conclusion. You also want to show the reader why you're drawing that conclusion. So with my example, with the two flu charts here, I think the chart on the left does that more successfully. It makes the point and also allows the reader to dive in and really see for themselves how this flu season has been different. So when you're deciding what goes into the middle of the chart, one thing to keep in mind is how your reader is going to perceive the things that you've put into your chart. So I'm going to start with a little bit about visual perception. This is based on a paper that I love from the early 80s, where they did experiments and had people look at different simple graphs to understand how they perceive the information that those graphs contained. And I'm not going to go into too much detail on visual perception because I know that Adam has covered that in more detail, but just the takeaway from this paper is that there is a hierarchy to how well people can read numbers off a chart, basically. And the easiest task when you're presented with visual information, people can read most accurately if you're comparing numbers along, a single linear scale. So comparing lengths in a bar chart, comparing positions of dots along a single axis, and a scatter chart is just like doing that twice. So if you really care about conveying precise values, a length, putting things on a single axis is your best bet. Second, below that is comparing angles and directions and areas. Areas are, they give you a ballpark sense, but it's hard to get precise comparisons with areas. Angles look sort of different. We perceive them differently depending on how they're oriented. And same with directions. So those, are useful tools, but just know that when you use them, people may not be getting the precise values out of them if that's what you want. And then third, the lowest rung of the hierarchy is volume. Volumes is very difficult, especially when it's just drawn on a two-dimensional sheet of paper. But it's hard also, like if you're just like pouring water from one vessel to another, like comparing volumes is a difficult task for the human brain. Curvatures are also hard to differentiate. And then shading and color, our eyes are good at picking up differences in color, but it can be tricky. And I'll get into color in a little more detail in the next section. And so this piece I included because it's a thing I did for for popular science while I was on staff there. It's a chart about energy usage in the U.S. And so it appeared on 2 pages of the magazine. And my point is, with including this, is that when you're, reading text, to start at the top and move through it to the bottom. But when you're presented with a visual, you really have to help the reader know what to look at first. And if you're presented with a bunch of stuff at the same size, the eye doesn't really know where to start. And so whatever your most important point is, you make it the most visually clear of all the elements on the page. And so the main point of this graphic is the difference between the energy consumption in the US and the energy production in the US. Consumption's in purple, production's in blue. And then the difference between the two is basically, at some level, just how much we import as a country, and that's in red at the bottom. And then the thinner lines are all about the historical predictions for those values, which is interesting and informative, but not the main point. So those are much fainter. Anyway, the point I want to make here is that think about how the reader approaches it. Their eyes, I've created 3 sort of continuums over on the right here, where the eye starts with the biggest thing and then it moves to noticing the smaller things. It'll start with thicker lines and then pick up thinner lines later. It'll start with brighter colors and then or more high contrast, like if it's on a black background, a dark color, whatever. Brighter to fainter, more contrasty to less contrasty, I guess. And so you can use that to your advantage to help your reader navigate the chart the way you want them to, by making your biggest, most important point in your brightest colors, your biggest fonts, your thickest lines, and then secondary information sort of a notch down from that visually. And then I also want, if you're thinking about visual perception, I just want to make the point that a chart form that your reader is familiar with goes a long way. So I've put a bunch of pie charts on this slide because I actually love pie charts. I use them very carefully. I only compare, it's a part of a whole. These are the ones in purple are all ones that I did. They're all in the popular science style. So they look the same, but the point is that they are a very useful visual element. Like the circularity of the chart grabs your attention. If you've got like 20 sectors in your pie chart, people aren't going to be able to understand it. But like if it's 1 or 2 numbers that you want to compare and you have the space to label it clearly and make sure that, like, people rag on pie charts because it's hard to actually read values off of them clearly. But I argue that if you're using them as a very straightforward and simple device, they can be quite powerful. Also, this meta pie chart is just like my favorite thing ever. And I'm not saying that a pie chart is the right thing for whatever point it is you're trying to make, but I just want to say that, like, if there's a standard chart type for a specific type of data that's, you know, standard to your subfield, then like obviously use that. But and if you're like, if you know that your readers are going to be familiar with a particular chart type, then that's worth a lot, because, you know, people know how to read a pie chart, and that's valuable. People know how to, you know, spectroscopists know how to read a spectro. That's valuable. So I'm just like, don't throw out the conventions, you know, modify them to make them work the way that you need them to work. Like, I'm going to use my pie charts in a very specific way, but I'm still going to use them. And if you want more ideas about perception and charts styles, I have two books that I love that I recommend. This one is by that same William Cleveland, who wrote that paper. This book is just great. He's a scientist, so a lot of his examples are science examples, and it's just a lot of really good, straightforward advice about how to make a clear chart. I just, you know, really, I should have just said read this book instead of listening to this talk, because he covers how to draw a trend line so that people can see differences, how to do multiple, like, inset plots, the best practices for axis. Like, I didn't have this book in grad school, and I really wish I had. I mean, it existed. Look at it. It's ancient, but I think that's a great book. This is a slightly more modern book, and it's much more data viz-y. You know, like, here's the Times charts about how people, you know, how the U.S. has voted over the years. It's much more generalist, and it's much more about, like, trends within the data viz community, but there's a lot of visual principles in here. She goes into a lot about visual perception and area and color and all of that. And it's just, like, kind of a pretty fun book to read. So I also recommend that one if you want to learn more. So a little bit more about color. This next couple sections I'll move through pretty quickly, but I just wanted to, because they're core elements of graphic design, I wanted to touch on them. So color. Color does a lot of things for a graphic. It helps you draw attention to whatever it is you want your reader to pay attention to, like the brain cover of science. I just grabbed some recent covers of Science and Nature that are, like, graphical in their approach. And it can help you show when something is important. Like, you can just use a little spot of color to call attention to something important. You can use color to differentiate category. So color all of, you know, some type of something blue and some other type of something red. You can use color to create some emotion. So, you know, this Waiting for Spring cover has a, like, calm and winter feel. The green of the plant cell, like, that's obviously artificial color on that cell, but they've chosen it to be green, and that instantly makes you think, oh, this is a cell of a plant, and it is. And so you can just make simple color choices that will help reinforce points that you're already trying to make, or just help draw attention to the parts of the graphic that you want to draw attention to. This is a piece I did for Audubon magazine a couple of years ago, and it's a, like, complex map with a lot of detailed layers. But I just want to point out where I've used yellow. Like, I save yellow, the brightest, most eye-grabbing color, to help draw connections between the sites along the Gulf Coast. This is a piece we did that Audubon did for the 10-year, marking 10 years since the Deepwater Horizon So we wanted to call out specific spots where restoration work is happening. And so I saved my yellow dots for that to help the reader make close, like draw connections between the map and the captions. So that's just like a little spot of color, even though the rest of the map's obviously colored. And if you have to choose colors, I love, love, love ColorBrewer. You can check out the website, but I just did a screen grab of the interface. It helps you based on how you want to use color. Like if you want to use color to encode values, like to bin your values and to do it by color, it gives you gradient color schemes that move through color, but also from dark to light so that it's both the saturation and the hue that are reinforcing the point, the scale that you want to be using the color for. I use it as a starting point. For the work that I do, I usually need to adapt it or come up with my own colors, but for just like basic direction on how to choose colors, it's just great to play with because you can do all these filters to make sure that you're choosing things that are going to be safe for people who are colorblind, things that will print well in black and white. It's just, I recommend it highly. And then a couple of quick cautions about using color. Don't forget, lots of people are colorblind, especially in here in the US and in Europe. I think the rates are lower elsewhere in the world, but it's roughly 1 in 20 people are colorblind. I use a little app called Color Oracle. And I just have it installed, and you just hit F5 and it makes your whole screen simulate color blindness. You can just like tap that as you're designing and just like confirm that what you're working on is going to be legible to people who are colorblind. It's not like I have done stories on color blindness, and I asked the experts about this app, and they were like, yeah, it's okay. It's not perfect. So it's not perfect, but it does give you a great sense of how people who are colorblind see the world. Don't forget that sometimes people print things in black and white like crazy people, and so your colors might just totally be washed out. So don't use it for anything super important is my recommendation. If you can, like obviously everything here is to be taken with a grain of salt depending on what you're actually trying to accomplish. If the colors are sort of mixed up, like the same color will look different depending on what colors it's next to. This is a book that I have on my shelf, but I took a picture of it for you so that you can see that, like, those squares are the same, the color top and bottom, and then the backgrounds are different and the colors on the inside look different. So just keep that in mind when you're like, just choose colors that are different enough that you can still be like, oh yeah, blue, got it. So I guess what I mean is that color is important, and don't rely on it. At the same time, don't rely on it too heavily. Like, use it to support your point, not to make your point, maybe is what I mean. And then quickly, I want to touch on fonts and font choices. I know that, very often you're starting with a system default on a font, but I just wanted to mention a few things that I think about when I'm deciding what font to use. So these are just some like very widely available fonts that ship with all the machines. So there's 3 broad categories of fonts: serif fonts, sans serif fonts, and monospace. These are some that appear on most machines and that I like, generally speaking. I think I wanted to mention that there are studies. I did not dig up the actual study, but there have been legibility studies about fonts, and I think there is sort of a notion floating around that sans serif, because it has like fewer like little bits to it, is more readable, but it's Actually not. Readers do the same. Do they read equally well in sans serif and serif? There's some argument like the little caps on the letters actually help you distinguish between them, which can be useful if you're making a chart, because you might have just a few words or some numbers that are, being put in as labels, and being able to tell the difference between an uppercase I and a lowercase l and the number 1, and a 0 and then O is actually pretty important when you're thinking about chart design. And so I think it's worth it to spend a little time with fonts and just sort of figure out what your favorite ones are and then just use them. It's not a problem you have to solve every time. But I, for example, have figured out which font I have favorite fonts that will have, I have favorite fonts that have the little curly bottom on the L so that you can tell when it's a lowercase l and when it's a number 1. And I like fonts that have little caps on the I's, on the capital I's. And then the monospace fonts are great if what you need to make is a table, because then all your numbers line up beautifully in vertical columns, and it makes it very easy, even if it's like a text and numbers combined table. And Courier, I think, is just a gorgeous font, and I would use that all the time in tables if that's what you need to do. So that's my quick 2 cents on choosing a font. And then in terms of how you use the fonts, I just wanted to draw these 3 ways that you can adjust your font to help with that visual hierarchy, where you want the most important point to be the biggest and clearest, and then the less important points are smaller. And so I think of it as 3 axes that you can use, some combination of them. Fonts come in different weights, and so a heavier weight of a font will be will catch the eye more readily. Capitalization feels more important than sentence capitalization or title capitalization in the middle there. And then bigger is going to be more eye-catching than smaller. So that's just a simple hierarchy to keep in mind, so that you can use your labels. You can design the labels on your chart to follow that hierarchy. I want to talk very quickly about error bars, and there's just 2 things I want to say. The first is that when you're using error bars and you're not speaking to people in your field, then, and even if you are speaking to people in your field, it's just super important to be really clear about what it is your error bars are showing. It sounds obvious, but this was a paper in Nature Methods a bunch of years ago. And there was a study that was not this study, but the study that's referred to here. They were talking to medical, like behavioral scientists and psychiatrists, and not people in quantitative scientific fields, but still, so with a grain of salt, people have a hard time actually understanding what it is the error bar represents and how that affects the statistical significance of the findings. That it's just error bars are kind of tricky for people to judge, and different fields have different conventions for their error bars, and so it's a 95% confidence interval is pretty straightforward and pretty well understood among different fields. And so they recommend, and I am mentioning it because I will agree, that if you're speaking to a general science audience, the 95% confidence interval might be the thing to display, if that's appropriate. And also, I just want to make a plug for error bars without end caps, without little hats on them. I just like it better when I think it looks cleaner and there's just less clutter. But obviously, it's going to depend on the number of points in your chart and what you're actually trying to display. But I think that without the cap, it also sort of helps you mentally, like the cap makes it feel like this is the full range of what this value could be. And if you're doing, like 1 sigma or whatever, then it can be beyond that. And I feel like without the cap, it sort of implies that it could go further. Those are my 2 cents on error bars. I've just realized that you guys are here in my office for what I call Chimney Hinge, which is at certain times of year and times of day, the sun cuts right through the bricks on the chimney, which is on that wall there, and shines my little chimney hinge on the wall. Anyway, penultimate section is annotations. So by annotation, I mean all the extra text that goes onto the chart. And text and graphics. Maybe not text, maybe just an arrow. I pulled this together from some random Google searches and some trolling of the Hubble outreach pages or press releases. Because I don't know, I always remember like sitting in a colloquium about supernovae or whatever, and I just always love when a researcher has taken the time to put a little arrow on their chart and show me exactly what it is they're looking at. I just like, when you get the 2 pictures where they're like, oh look, there's no supernova, and then there is a supernova, and it just clarifies it so well. And so I just created this little visual ode to different ways that that you might annotate an astronomy image. Like maybe it's just marking what your targets are. And maybe it's something a little bit more explanatory, like if you're talking to a general audience for an outreach talk or a press release or something. The like time series on the Fomalhaut planet. I think there's a lot of great information to be made with these sorts of annotations. And for myself, when I make these annotations, I do my work in Adobe Illustrator, which is a professional designer's piece of software. I use that, and I use Adobe InDesign which is like geared toward print layouts. And they both, have taken. There's a lot you can do with those programs, even as sort of a novice. You can learn to do the 5 things you need to do in those programs. And I'm mentioning it just because my sense, whenever I try to put annotations on charts procedurally, when I'm coding up the script to make my figures, there's just so much fiddling when you're trying to do it procedurally. Like, oh, is this the X and Y coordinates that I want? Is this area? Yeah. If you've got a program like Illustrator, or there are free versions of Illustrator, one is called Inkscape. They're just open source knockoffs. They allow you, if you can make a chart. So this is how I work. What's my next slide? Should I be talking about this right now? Yes. Okay. Yeah, I'll return to that point. Okay. This slide. Sorry. Yeah, I put some annotations on these sample charts that I made up for the purposes of to give our discussion some focus. So, as a reader, maybe there's one object you want to pull out as exemplary somehow, or, if you've chosen to go this route where you've colored your 2 populations differently, having to go back and forth between the caption and the graphic just takes some mental energy on the part of your reader. And so if there's space and you can do it, I think it helps a lot to put information directly on the graphic where possible, just to help give readers just enough information to help understand what's happening without having to go down and read the caption. I want my readers to look at my graphic and I've got text on it so that it is really clear what I'm talking about, but also if you can get it at a glance, so much the better. So I'm a big advocate of just putting words directly on charts. And I think what I was trying to say in my rant about Illustrator and Inkscape is that it's just so much easier if you can output to some kind of vector file format, like a PostScript or a PDF, and then open that up in one of these programs. So like Illustrator and Inkscape are for vector format files, like Photoshop is for raster images. So I work mostly on vectors. So then you can just like take a block of text and an arrow and plop it exactly where you want it. And it's, sort of a last step and not something that's done procedurally, but sometimes it's just like the best way to do it is just put it where you want it and not fiddle with a bunch of code to try to place it exactly right. So I highly recommend doing this, maybe knowing what it is you want to annotate at the beginning, but once you get the rest of the figure in place, then you can go in and, once you've done that modification in the Illustrator or Inkscape, it's a kind of a pain in the butt to reproduce the figure. And like, then you have to do all that again. So I recommend doing that at the end as best you can. So I think annotation is one of the most powerful tools in your arsenal for making sure that the reader is getting what you want them to out of the chart, because it's a chance to really like point at the thing that's making your point and say, look, here's the thing that's making my point and why it's making it. I use captions and annotations extensively in all of my work because it exactly allows me to be like, here's the guts of the thing. Look at this right here. So other reasons I think it's powerful, just quicker to parse what's going on in a chart if you've got labels right on it, as opposed to down in the caption. And, maybe you who've been sitting with this data for a long time feel like you're just like like maybe you're saying your point too much. Like, is this overkill to also put it on the chart? And I think it is not overkill to also put it on the chart, because maybe your reader is just flipping through quickly or skimming the paper. They haven't read any of it. They just see this one chart and it grabs their eye because it's got some nice little colorful annotations on it. And then they engage with that and they get the point, and then they move on to whatever it is they're actually leafing through this paper journal, apparently. I'm miming someone in the 1800s reading astronomy. Yes, okay, sorry. I think it's not excessive to make your point many different ways, because you're trying to meet your reader where they are. Like, maybe they're going to be reading through it carefully, maybe they're not. And either way, you're going to catch them and help them understand what it is you're trying to say. And then lastly, the caption, all of the text that goes underneath the figure. And I'm talking about it last, but that does not mean that you should write it last. I just want to make a distinction between the like afterthought caption and a caption that is like part of the whole, and it's like an integral part of the figure. So on the left, I have re-entered the trap that I fell into always when I was writing my first drafts of papers in grad school, which was that I would finish this figure. And obviously this is not a finished figure. I don't have axes or anything. But whatever. I finished the figure and then I would be like, oh crap, I got to write a caption. And then, it's just like, you're mentally deep in the figure at this point. And so I think it's hard to approach it from the reader's perspective if you're like so deep in it that when you get to the caption, you're like, boilerplate. This is the things that I'm showing, which is definitely what I did. And I think instead, perhaps, the caption can be a way to is valuable space for making the point that you want your graphic to be making. So we so maybe if it's possible to like sum up the point of your chart in a single sentence, lead with that and put it in the first sentence of the caption, and just be like clear, like, look, these stars we've discovered fall into two clear, distinct populations. And then you can like work in the coding that you need to do with like what orange represents, what purple represents, or better yet, put them into annotations on the chart. And then, I'm thinking of this almost as like a little mini news story where like the most important information is in those first couple sentences. The lore, at least in journalism school, is that they did that because like wire services would put the important stuff at the top, and then like write more and more background all the way down, so that literally they would be cutting the pieces to fit into, like, then they would send that story out to all of their affiliate newspapers, and like they would just cut off the bottom. Anyway, that's a little digression into the history of newspaper publishing, because that's what you get when you hire a journalist. Sorry. What I mean is that don't be afraid to like state your point clearly right at the top. Maybe that's the only sentence people are going to read. And then if they continue going, like there's going to be work that the caption needs to do. You have to, you can use the caption to your advantage by stating your point one last time. And like, yeah, the caption's going to have a lot of heft, like it's got to do the work of explaining all the stuff that you needed to explain, like what the dots mean and what the error bars represent and everything else. But maybe just don't put that at the top. Put that down at the end of the caption, and let the start of the caption be a space where you can really make your point one last time. Because making a point is your point. See, I just made that point one last time. That's it. Thanks, everybody. Thanks, everybody.